Hey there everybody, this is Devin Olson, and today we're going to discuss the Unity 3D game engine's external light mapping tool to properly light and shadow our model in Unity 3D. So to begin, I have 3D Studio Max open and my model selected. I go to the modifier list and I add two unwrap UVWs. The second unwrap UVW needs to be set to channel 2, and the first one obviously channel 1. Unity sees anything on channel 1 as the original texture coordinates. Anything on channel 2 is specifically for light map coordinates and will not affect our channel 1 however we edit it. So going back to 2, we can click the edit in the parameters flyout and we get a preview of our entire model's coordinates. And immediately we have two issues here. Our coordinates are overlapping a lot, and to get a proper light map we need to make sure that our faces have unique real estate, they don't overlap at all, and our collection in a whole well falls out of our power of 2 desired dimensions for creating a light map, such as 512 by 512, 1024 by 1024, and so on. So we can quickly fix these two issues by pulling out the flyouts in the unwrap 2 and select face. Come back to the preview window, click Control A to select all faces, and now we'll go to mapping, flatten mapping, and change our spacing to 0.001 and click OK. And once max is done, you'll see it's separated all of our coordinates so none of them are overlapping and they all fall in our power of 2 desired dimensions. Great. Now we can save this model by going to File, Save As, and save it within your Unity project. I'm calling mine Building. Now let's go over to Unity. We'll go up to Terrain and create a new terrain, and now we'll throw our new building model onto this terrain. Now we need to create a light that will represent our sun. So go to Game Object, Create Other, Directional Light, and we'll move this above our scene. As well as offset it from our building. And we're going to rotate it towards the corner of our building. So hopefully we'll get some nice lighting hitting the corner of our building, and we'll get some shadows coming off all the little objects on the front of the building as well as the top. Great, so with our sun in place, we'll go to File, Save Scene As, and I'm going to call this Building just to be consistent. Hit Save. And now it's time to talk about the external light mapping tool. So if you go to Window, you should see external light mapping tool here. If you don't, you need to install it prior to opening up Unity. You can find it on the link below. It's provided on Unity's website for free. So once you have it installed, go ahead and click this and you'll get our tool come up, and let's go ahead and drag from our hierarchy the building model right into the tool here. These are all the materials that make up our single model here. You can change their types within the scope of external light mapping tool to bump specular, bump diffuse, alpha, all of these guys. Just make sure they're within the scope of an external light mapping tool. Great, so if you have no errors here and everything's set to the right scope, let's go ahead and hit Export Scene. And Unity will write our UVs to an FBX temp file that we'll be using to create our light map. If you get an export successful message, click OK, and Unity will begin to open up 3D Studio Max for you. Alright, you can see in our scene we have our model again, but this time we have a light that came from Unity that set up specific coordinates that we wanted to back out in Unity. Now again, this light represents our sun, therefore it will be our directional light and will create our large high contrast shadows. But for a real or a more photorealistic scene, we also need to include ambient lighting. So to do that, we'll go up to our Create tab, Lights, Standard, and create a skylight. And we'll just place it anywhere in the scene. So with the skylight selected, we'll go to the Modify tab and make sure you have under Renderer Cast Shadows checked. And we can play with our ray sample and our ray bias here. The lower the ray sample, the more blotchy or noisy the ambient shadows get. The higher they are, the more clean, but it takes a lot longer to render. So I leave mine at 20 and my ray bias down to 0.001. And I'm going to set the multiplier to 0.7. Let's come up to our imported light, and in the shadows parameters, let's change this to ray trace shadows, and let's go to the shadow parameters, and we'll change the density of the light to 150. Great. So we have our lights set up, our models in here, we've got our coordinates ready to go. So all that's left now is to go over to our new tool that opened up with Max and click the Bake All Now button. So what Max is doing is it's taking our Lightmap coordinates, our two lights in the scene, and it's baking a light map for Unity. And once this is done, Unity should automatically be updated once we go back into it, and we should see a dramatic change in our model's quality and lighting. Alright, now here we are back in Unity, looking at our model with the new baked light map on it. And you can clearly see that we've got our directional light shadows coming off of all the little objects such as the satellite and the cloths hanging over the windows, as well as our little air conditioners up top in the buildings, antennas. Everything's looking great. Our ambient lighting on the inside got picked up. What I have here, I've turned my light down just so I could show you the shadows. The next step would obviously be to enhance the textures with bump maps, normal maps, specs, whatever it is that's of your desire. I've gone ahead and done that. So if I increase my intensity on my light to, let's say, 0.5, you should see all of these extra textures come in. And now that's looking great. So with our ambient lighting, direct lighting, and basic normal mapping, bump mapping, we can achieve some really close to photorealistic models. And that's it. Thank you very much.